Well, how are you doing? Okay, this will be hopefully a pretty short video that's going to absolutely debunk the globe outright. We got a lot of claims. We've had a lot of claims since January 2020 when the Black Swan photograph came out, or I should say the argument, because that um, there's been photographs like that for a long time, but uh, we've been told that the horizon is a refracted position, right? And now, obviously, that's a lot of rubbish, as the Black Swan argument kills that. If you understand the Black Swan argument, saying refraction is a destruction of the globe. Once you understand the Black Swan argument, making refraction your rebuttal is absolutely pointless. Because it's like as if you're cutting your own legs off. But anyway, we're also told over the years that Polaris and its apparent position in our sky is a proof of a globe Earth. Now, in my last video before this, it's a 41-minute video, I detail how the flat Earth elevation angles to Polaris is where the globe Earth's radius value has been back calculated from, and I show how it was all done and how it happened. But as I'm that video is not being addressed by our opposition, I need to step it up one more and point something out that they're not taking into account. Now, I have had some people on, some very prominent people on our opposition side, clearly state to me, I won't show you who they are, but they've clearly stated and they've written to me that the horizon is not referred to when we're taking elevation angles to Polaris. So the sea horizon and horizon in general is not referred to when we're taking elevation angles to Polaris, right? But elevation angles to Polaris is what gives us our latitudes, right? And as you will see, that the claim that elevation angles to Polaris does not involve the horizon, as you will see, is that claim is completely false and completely wrong, as I'm sure most of you already know. But I just wanted to state that we have prominent members of our opposing side stating that elevation angles to Polaris do not reference the horizon, especially the sea horizon, right? Right, so here we go. This picture here, this is reality. This is what we see. We don't see orthographic, we only see perspective. This is perspective view. Here is the sun. Here is the sea horizon. There's some land over here and over here. This is a zoomed in of a bigger picture. But this is the sun. This is the horizon. So the angle is measured between this line here, where the sunlight is, right here, and right, that will be your adjacent, and your hypotenuse, which would be pointing towards the sun. And then you will have the GP from the sun down here, right, somewhere in the distance, that will give you your opposite, right? So you have your zenith from the GP giving you your opposite. You have your adjacent along the water here, stretching to the GP, and then you have your hypotenuse, which will meet the opposite, and which is determined. The length of the hypotenuse is determined by the length of the adjacent, right? That's reality. That's how we take an elevation angle, and it requires a 90 degree. You can't create an elevation angle to a celestial body without the 90 degrees. All elevation angles require 90 degrees, regardless of what you're measuring. The whole point is you're measuring an elevation, right? You're measuring a change in elevation. That's what you're doing, right? Or an altitude, right? Right? You're trying to measure an apparent angular altitude. Okay, so this would be, if we were going to measure this, it would be whatever between be probably about, I don't know, would it be 45, 50 degrees, whatever it would be to the sun. Let's say we use the lower limit of the sun between the horizon, the sea horizon, which is just our natural horizon, and the sun. That would be how we would measure it, right? We'd create a horizontal baseline, the adjacent, along the surface of the water, stretching to the GP, and the hypotenuse then would give us our angle between the sun, the lower limb of the sun, and the sea horizon. So simple stuff. That's how we measure it, right? That's how you measure, because you're measuring perspective. That's what you're doing with angles. That's how angles work. The whole point of angles is that they measure perspective, Angular size change. What's that? It's not actual size. It's a change. It's an angular size. It's a way of determining. It's a way of measuring perspective. And determining distances and sizes of sizes of objects in the distance, and that when we're dealing with like Earth-based stuff. But when we're dealing with celestial bodies, it works exactly the same. It's just you can't determine certain things like distances and heights to the actual celestial body. It's all apparent. But that's the whole point. All angular measurements are only apparent. There's no angular measurement that is an actual measurement. There are apparent measurements, right? But anyway, this is just reality. I just wanted to point out a bit of reality before we go into what I'm going to go into now. Okay. So I'll show you this again in a minute, another version of this. So this is showing the star. Here is the horizon. So this is with an astrolabe. But the whole point is that it's the angle to the star, let's say this is whatever star, is taken between the horizon and the star, right? So this is like an orthographic representation of what we saw a minute ago with the sun, right? But it's always referenced off the horizon, right? Now, in particular, Polaris, right? In particular, the elevation angles to Polaris always reference sea level. In particular, right? Because that is how it has to be done for everything to be done correctly and for all the latitudes to be correct. It's all based off of sea level. That's the best right now, because they were using marine sextants when they were doing it. So they didn't have bubble sextants, and they weren't using artificial sextants. Didn't have those either at the time. So they were using maybe astrolabes or marine sextants, that kind of thing, right? So it was mariners who started using the celestial bodies that we know of. Mariners who first started using them for navigation. So mariners would have to use the sea level and the sea horizon for all elevations, right? So just need to point that out. At all times, all angles to Polaris were all determined off of the sea horizon, right? From its GP point to the equator, that 90 degrees of angular distance, that was always determined off of the sea horizon originally. Now you can take an angle, the same angle to Polaris 6 miles straight above your head. So if you're at 45 degrees and you have obviously 40, which is determined by your 45 degree angle to Polaris, and you are 6 miles above in an airplane, you take an angle to Polaris and you will still get 45 degree angle, because the celestial bodies work different. A lot of people don't realize that, and that's a bit difficult to take on board, but it is actually a fact. Your elevation, you're changing your elevation doesn't change your angle to Polaris or any other celestial body, as long as you hold the same zenith and you're taking the angle at the same time. So you can take an angle off of the sea level, off of zero, right? And someone else can take the same exact angle from an airplane 6 miles above you, and both if you take the same, if you're both referencing the same celestial body and you're both taking the same angle at the same exact time, then you will both get the exact same angle. So elevation doesn't change the angle to the celestial bodies. There's something a lot of people don't realize and don't know. And that was a bit difficult for me to take on board, because naturally you want to think that, but if you're raising an altitude, it's going to change the angle. No, not with the celestial bodies. They are different from everything earthbound. So just going to move on. Okay, here we have, these are not my diagrams. These are official diagrams from wherever. This is the O'Reilly.com library view, the complete guide, the blah, blah, blah. But this is all official diagrams, right? So they're referencing here globe Earth's geometric horizon at all times. You have local horizon here, but it's referencing the actual curved geometric horizon of the globe. Sun or starlight from Polaris is claimed to come in parallel, and as a person moves from the North Pole down along the curve of a globe Earth, then their angle, right, the angle between the horizon and Polaris, right, is claimed to change, right? That's how it's. This is always done in orthographic, because all globe maths is orthographic, so you always have to show you everything orthographically. There is no perspective included in globe maths. It's hijacked by heliocentrism, right? So you will not have any perspective included in globe maths. It will always be in orthographic. So they have to show you in orthographic this is the explanation for why the angle to Polaris changes. But this angle is an impossibility on a globe or curved surface anyway, but that doesn't matter. Right now, what matters is they're referencing their geometric horizon. That's what they're referencing right here, right? They're not referencing anything else, they're referencing the horizon, which is this point right here, which is their geometric horizon. Because they, right, and every one of their diagrams keeps on referencing the geometric horizon, because that's the one they are referencing. Here we are again, horizon, right, geometric horizon. There is two Polaris, as you can see, right, I say the claim of parallel light rays, which is a different argument. And as you can see, there's a 50-degree angle here. That would be a 90-degree. Down here is a 50-degree angle. That's how they work it. And then as you get to the equator, then what blocks you when you get to the equator? The geometric horizon. That's what's claimed to block you when you get to the equator. So what's changing your view to Polaris is the globe Earth's geometric horizon. This is the official claim. Officially, it's the geometric horizon, right? Which I'm going to prove in a minute. Now, here we are again. Same again. You have Polaris horizon, right? Right. So it's all being every elevation angle or every angle that they're showing here is referencing the globe Earth's geometric horizon, right? This here they might be putting in these tangent planes, but that's just for to create the diagram. It's all referencing the geometric horizon, because the claim is that the globe that as you go back down here from the North Pole down to the equator on the globe, is that as you go down here, then the angle changes to Polaris, and that angle then is reversed and put into the center, and it gives them a distance along their surface. That's how they back engineer it, right? As opposed to it being horizontal, right, in perspective. But they have to back engineer it. But the whole point of this is that all the latitudes and all the distances down along here from the North Pole to the equator, every part of that involves the curve of the globe Earth. It involves the geometric horizon, every single part of it. Every single elevation angle to Polaris off of the horizon, right, has to come from a globe's geometric horizon. Otherwise, the globe will not match all the elevation angles to Polaris. They have to use a globe's geometric horizon to do this. This is the claim, right? This is the orthographic claim. They have to claim that they're using the actual curve of the globe Earth and a globe's physical geometric horizon. That's what they have to do. Same again here. You have the horizon, you have Polaris, then they're showing a 30-degree angle above it. Obviously, they have to show this part, right, with a big tangent plane, because they need a horizontal to create the angle, but they're still referencing their geometric horizon. It's all based on their curve of their globe Earth. Moving on, same again here. You have Polaris at the equator, where it's just on the horizon. Polaris at 30 degrees in New Orleans, Louisiana, all above the horizon. And at Polaris at the North Pole, it's 90 degrees above the horizon. So horizon, horizon, horizon. 3 horizons. And then they show it here. As you can see, they're adding in these little tangent planes, although those would be very big in reality, but that's what they're adding. They're basically trying to change horizontal. They're resetting horizontal as they need to. And here you go. This is all referencing these points, or they're referencing. They're all the geometric horizon of a globe, every single one of them, because those tangent planes can't exist in their model. Their model requires the curve, right? Those tangent planes are only part of geometry, right? And they're only in there to reference the angle. But the points that they're hitting, a tangent plane meets a circle at one point, right? So that's how that works. It's just every point that they're hitting is the geometric horizon of a globe. This is the official claim. This is how it works. This is how it has to work for the globe to have a radius of 3958 and change. That's the actual radius, but it's rounded off at 3959. nautical statute miles. So the globe has to have that radius, right, to match the observations to Polaris. It has to show this orthographically as tangent planes down along a globe. They have to, right, they have to have a radius that's 3959. Otherwise, the observations that we see, if their radius was any bigger or smaller, it wouldn't work. And the radius comes from flat earth, it's back engineered from flat earth elevation angles to Polaris, as I showed in my last video. Exactly how it's done from start to finish. It's such a simple thing, but yet it has hoodwinked the whole world. So what I'm really stressing here is that they are referencing a geometric horizon at all times here. Okay, once again, this is from WS, one of these nonsense flat earth debunker people. Here we are again, that's the geometric horizon of the globe, all the way down, right? This person, geometric horizon of the globe, right? You can see it, exactly what's being referenced. Here we are again, this shows all the latitudes. All the latitudes require the geometric horizon of the globe for it to work on their model, right? They can't have anything else. They have to have the geometric horizon. This is from this site, w.astro.berkeley.edu. It's up here, and this is where this diagram comes from. Where is it? Here, it's down here somewhere. Or it was there. It is. So, so latitude, right? Boulder is Boulder, Colorado. Is 40 degrees north latitude, right? I think it's Boulder, Colorado, right? North, south, North Star, Polaris, 40 degrees, right? Right. To measure latitude, measure angle between Polaris and the horizon. So, for anyone on an opposing side who's trying to claim that they're not referencing the horizon, that's completely false, right? It's the latitude, all latitudes are based on the angle between Polaris and the horizon. That's specifically the sea horizon, because that's where the first measurements came from. So it's to measure latitude, measure angle between Polaris and the horizon, right? So here we are again, another, this is from Wikipedia, or Wikimedia, so this is from Wikimedia, I don't know where it originated from. Same again, there is the horizon and Polaris, so they all have to come from the horizon, every one of them. And they're all referencing, in orthographic view, it's all referencing a globe Earth's geometric horizon, every single bit of it, right? So here we are, back to reality. This is what we actually see. This is the sun over the sea horizon. You know, that's what we see, the sea horizon. That's, we only have this horizon here. Here we are again, sun over the sea horizon. That's our horizon. That's what we see. That's what it is. Here we are again, sun over the sea horizon. Sea horizon, that's what it is. There we go, over the horizon, the sun, right? And again, there's the sun here over the horizon, right? So this horizon here, is that geometric? Well, let's just, no, that's not a geometric horizon, because the horizon we see is not geometric. It's apparent, not geometric. So, and this is where things get interesting. Angles to Polaris modus tollens. If P, the angles to Polaris that give us our latitude positions, are taken between Polaris and the globe Earth's geometric horizon, then Q, the refraction calculation of 7/6 or 7/6 of radius, would have to be included in all the angle measurements to Polaris. Not Q, the refraction calculation of 7/6 of a radius, is not included in any angle measurements to Polaris. So not P, the angles to Polaris that give us our latitude positions, are not taken between Polaris and the globe Earth's geometric horizon. This is a major problem that they cannot ever get away from. This is why. Logically, this debunks the claim that the horizon is a refracted position, refracted up from a globe Earth's geometric horizon, as all the angles to Polaris use our visible apparent horizon, which means that all our latitude positions are determined by the angle between our visible apparent horizon and the apparent altitude of Polaris above it. So logical inference would obviously strongly suggest that elevation angles to Polaris debunk the very existence of a globe Earth, as our visible horizon is apparent and not geometric. See Exhibit A. It's not a geometric location, it's apparent location. Yet it is these very angular measurements taken between our visible apparent horizon and Polaris that were hijacked and back calculated into a globe Earth's radius value. So this means that a globe Earth's geometric horizon does not and cannot exist. As for the globe Earth's geometric horizon and the globe Earth itself to exist, then every single angle measurement between the horizon and Polaris would have to have been measured between the globe Earth's geometric horizon and Polaris, and not a visible apparent horizon and Polaris as we use in reality. So if we were to take an angle to Polaris from this horizon here in the black swan photograph, then the angle to Polaris would match latitudes. It would match the latitude. So if we use this horizon here to take an angle to Polaris, right, then it will match, although it might be in the wrong direction, it would match, the point is that it would match the latitude. Yet this is claimed, although it's complete and utter nonsense, this was the only rebuttal that came for this argument from our opposition was that the horizon was refracted. Now, as I said earlier, that destroys their claim anyway, because if it's refracted, then it's not geometric. It means you've never seen a geometric horizon. It means it doesn't exist. But they have continued on with this claim and tried to muddy the water and try to confuse as many new people as possible into the topic and make people believe that the horizon can be refracted. But every angle to Polaris is taken off of the sea level horizon. That's where all the latitudes came from. That is where all the angles to Polaris are taken from. That means that the horizon that is being used is this horizon here in the picture, and not a geometric horizon of a globe. There is no 7/6R added in. It can't be added in because it's the use of this, it's the hijacking of this very horizon and all the elevation angles off of this horizon, the sea horizon, to Polaris, that were hijacked and turned into a globe Earth's radius value. And from there, all the orographic maths, all the orographic maths based off of what their radius would have to be at that to match the elevation, to match the observations that the elevation angle observations of between Polaris and the horizon. They are not referencing a geometric horizon when they're referencing the angles to Polaris. That means they're referencing the sea horizon. There is no 7/6R being added in because 7/6R is just a mathematical plaster. It has nothing to do with the angles to Polaris. So because they're not adding in 7/6R, right, into their Polaris calculations, it completely debunks their claim that 7/6R exists and a globe Earth's geometric horizon exists and the globe Earth itself exists. Because this is the horizon that they're able to take angles to Polaris from. This very horizon here. And it will always be correct. There is no need for adding of 7/6R. They will never, ever reference a globe Earth's geometric horizon. When they're doing it, it will never happen. So this very argument completely destroys every single bit of the globe Earth model. Every single bit of it. Because it all starts and ends with the elevation angles to Polaris and the hijacking of them. And to hijack them, they had to hijack reality, which meant they had to use the sea horizon and not as the sea horizon and not a geometric horizon that doesn't exist, belonging to their globe, which didn't exist even mathematically until after they hijacked the elevation angles to Polaris off of this very horizon, the one they say is refracted. Yet there's no refraction calculation ever needed or added in to the Polaris observations. The very thing that their whole model is built upon. Because if they added in 7/6R or tried to, it would make their globe smaller. It would change the actual radius and size of their globe, and then their globe would never match the elevation angles observations to Polaris. It's over. It's literally over with this argument. So I hope that share this, whoever is out there who is on our side, share it far and wide. This argument, you can make it small, tighten it up yourself, whatever way you want to do it. I had to go through it the way I went through it. The whole point is that you can't get elevation angles to Polaris that will match the latitudes using a geometric horizon of a globe. But that is exactly what they need you to believe is happening. No, it only works with the apparent sea horizon that we use and see all the time. It doesn't work with any globe's geometric horizon, and there is no 7/6 of a radius standard terrestrial refraction added in ever to the elevation angles to Polaris. The only refraction that's ever added in is when Polaris is below 20 degrees above the horizon. But for their claim to ever be real, then from word go, they have to start adding in 7/6R. From word go into every observation. And not one time is it ever added in. Because it doesn't exist, there is no globe Earth's geometric horizon, and there is no globe Earth. There is a globe Earth mathematical model in orthographic view. That's a hijacking of reality. That's all it is. That's all that actually exists. Thanks for watching.